Yeah, hi everyone, Mr. Markwick here. Today's video I'm going to show you how to construct a stem and leaf plot. Before I do that, I'm going to show you two examples of stem and leaf plot. So, first one you can see here, I've taken this again straight from the textbook. There's two parts to a stem and leaf plot. You've got your stem number and your leaf number. And the key at the bottom of a stem and leaf plot tells us how to read the data included in that stem and leaf plot. So, the stem number 2 and the leaf number 4 represents the data point 24, the number 24. Okay. One thing I'll point out with this stem and leaf plot is that you can see it's ordered. So the closer you are to the stem, the lower the number, and as you move out, the higher it gets. So you can see there. Sorry, I'll zoom back in. The two numbers I've just circled represent the data 12 and 16, and then the next line down I have a stem number of 2. So this 2 represents 22. This 3 represents 23, 24, and 27. So as you can see, as we move away from the stem, the number's getting higher. So it's ordered from the lowest value, okay, which is 12, to the highest value, which in this case is 59. All right. Now, the next thing I want to show you is a back-to-back stem and leaf plot. So back-to-back stem and leaf plot actually compares two sets of data. So we've got here, this example is the scores from the last 30 football games. On the left-hand side of the stem and leaf plot, I've got winning scores, and on the right-hand side, I've got the losing scores. And again, you can see that it's ordered. So the lowest losing score, for example, is 74. Again, I'm looking at my key, which tells me how to read it. 75, 78, 78, 79. My highest losing score is 111. If I'm looking at my winning scores, my lowest winning score is 81. My highest winning score is 123. Okay. So, back-to-back stem and leaf plot, great for comparing two sets of data. If you've just got one set of data, you just do it on an ordered stem and leaf plot. And we'll talk about this word you see here, skewed and symmetrical. We'll talk about those in a minute when I go through this example, because this example here I've taken from your textbook, page 541, and I'm going to go through this example and show you how to create a stem and leaf plot from the data given here. So for this set of data, they give us some numbers. Organize the data into an ordered stem and leaf plot. So what I'm going to do is, for my stem number, I'm going to have the unit. So you can see that the lowest score we've got here, if you look through this data, is actually 0.1. So my smallest stem number is going to be 0. That's my smallest unit. And the biggest number you can see there is actually 7.5. So I'm going to go all the way from 0 all the way up to 7. Okay, so once I've got my stem numbers on the stem and leaf plot, it's just about putting in the leaves now. So I'm going to start with the smallest value and work your way up. So as we said, 0.1 was the smallest value, so that's represented on here with, sorry guys, a 1. And as I go through, I'm going to cross off these numbers. So I've got another 0.1 here. There it is. That's another 1. And then a 0.3 is my next smallest number. So as you can see, again, as I'm moving away from that stem, I'm increasing. Now I'm moving on to any numbers that have a unit of 1. So starting with the smallest, it's 1.0. I'm going to move my way up. So you can probably fast forward here if you want, guys, and just see how I've recorded this at the end. 0.4 is my next. Okay, there you go. I've put all that data into that stem and leaf plot. It took a while, but we got there. What I'm going to do is I'm going to put a bit of a key down the bottom here as well. So the key is going to show you that, for example, stem number of 5 and leaf number of 2 means, in this case, not 52, 5.2. So that's why it's really important that you actually put that key down the bottom so that people can read it accurately. It's not 52 in this case, it's 5.2. Alright, now one other thing you'll notice there is that I've kind of lined up my leaf numbers so that they sort of sit on top of each other. So this is the first row, this is the second row, this is the third row, fourth row, fifth row, and sixth row there. The reason I've done that is I'm going to jump down to this last question here. So it says describe the data as symmetrical or skewed. So basically, I would say that this data is symmetrical because it kind of has that shape to it, a symmetrical sort of shape to it. If it was, heavy with data at one end, if there's lots of data up there and then it sort of skewed out that way, or it did it the other way, so lots of data at this end and skewed out that way, then we could say it's skewed. But at the moment, because it sort of is nice, generally symmetrical on the lower end and the higher end, I'm going to say that the data is symmetrical. Okay? Now, that's for D, data is symmetrical. I'm going to go back and do questions B and C. So it says find the median. Now the median is the middle number, and this is important because while we've ordered the data from lowest to smallest. So now I can work out how many numbers there are and work out what the middle value is. So we know that there are, let's actually count the data from the top. So the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 2. There's 28 numbers there. So there's 28 data points. So the middle number, if there's 28 data points, to find a median number or the middle number, when it's all ordered, you can actually do 28 plus 1 divided by 2, which in this case is 14.5. So my median value is actually going to fall in between the 14th and 15th value. Okay, and that's the middle number when I'm working out the median. Okay, that's a bit of a trick to work out the middle value. So in between the 14th and the 15th value. So let's count that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So here are my 14th and 15th values, and it's going to lie in the middle there. So we're going to find the average of those two numbers. Now those two numbers are obviously 3.3 and 3.4. So if I add those and divide by 2, it would give me a median value of 3.35. Okay, so the median of this set of data, or the middle value, is actually the average of two numbers, 3.35. Okay, and the mode, we know that the mode is the most occurring number, so the one that appears most often is 4.1. So the mode 4.1. Alright guys, basically if you had two sets of data, you could do the same with a back-to-back and go the other way here, but we only had one set of data, so I only just did an ordered stem and leaf plot. But hopefully you guys get the idea, and it makes it a bit more sense. Hopefully that helps. Again, if you're in my class, guys, the questions are on DayMat. So yeah, use this video as a bit of a blueprint, watch it over, pause it when you need to, and hopefully it helps. Thanks guys.